Hey guys, my name is Forrest Schwartz, and I'm here to talk to you about the baseball and physics lecture that I attended by Alan M. Nathan. Well, first of all, I want to go off by saying that I downloaded this video from his website, as you can see in this slide right here. This is his website, and you can get this lecture. It's actually really interesting, so I recommend you guys check it out. Well, first thing I want to say is that honestly, I found this lecture fascinating. He brought up multiple physics principles that apply to baseball, and many of which we've already begun to cover in class, and a few that we have not. He covered a few unfamiliar topics during this lecture, such as collision efficiency, trampoline effect, and the Magnus force on the ball. Basically, the concept of the lecture is to talk about the dynamics of the ball-bat collision and the flight of the baseball. The first slide right here, he talks about the forces, how the forces are large and the time is short. And this goes right into what we already learned in class about collisions. A really small amount of time of impact, really large forces, so we can kind of ignore a lot of the external forces. Just another relation to our class right now. But basically, the concepts that we don't really know about yet, collision efficiency, he goes on to talk about how that's really important regarding the ball hitting the bat. And then he goes to describe that to basically the sweet spot on the bat. Another thing we didn't really cover in class yet, the bounciness of a ball, knowing about bounciness, sort of. And, let's see, and what was it? The Magnus force, which is basically the rotation of the ball, which allows it to go further. Alright. So, some of the things that I found were extremely interesting. He showed at least 4 different videos of a guy hitting a baseball in slow motion, one of which was hit on the sweet spot. So in all these videos, he kind of shows the wave-like motion. On this slide, you can see it right here. Boom, right here. There's a wave-like motion when someone hits the ball in the bat. Now, if you hit it in the sweet spot, there's the smallest wave. And it shows right here, the graph, how that relates to the coefficient of, or the collision efficiency. The COR is maximized, and the BBS is maximized as well. It's the best field. See, vibration is minimized, so the lowest vibrational energy correlates to higher other forms of energy, such as the translational kinetic energy, which is another thing that we learned in the class. So this sweet spot minimizes the vibration, and it gives it the best feel, and that's how it relates to moving the ball farther. So, let's see. This concept of vibrations brought up another really interesting concept, and this is what I thought was the most interesting part about the lecture. If you go right here, see this, he shows, boom, that thing, how once you hit the bat, there's kind of like a wave-like motion. He's hitting it at the end of the bat, so there's obviously an extremely large wave. But as you can see, he says that the bat struck at the barrel, the handle starts to move only after noticeable delay. When reflective wave reaches the barrel, the collision is over. Therefore, nothing on the handle end matters. Now, this shows that you can just let go with the bat afterwards, because the handle end doesn't even matter. So, you don't even have to be holding on to the bat right before the collision to hit the ball well. See? As in right here, he just lets go of the bat, and the ball still has the same trajectory. And I thought that was really interesting. I thought you would obviously have to hold on to the bat, and that would have some effect on it. So that was pretty cool. So what did he go over that we already knew? Well, the good thing about this lecture was that we have an introductory education on almost all the concepts in the lecture. We have already gone over air resistance, which has an effect on the flight of a ball, and we have also begun to discuss collisions and how the conservation of momentum combined with the energy principle can be used to determine the final speed of the ball, along with other concepts related to the change in energy of the system. For example, our knowledge of collisions allowed me to somewhat grasp the concept of the trampoline effect. Now, the trampoline effect then goes on to describe why aluminum is better than wood, and the reason why that is because of higher bat speed, lower collision efficiency, and net wash. Basically, when you hit it with aluminum, it compresses more than the wood, and therefore it kind of generates a trampoline effect. It generates more momentum into the ball. Now, one of the things that I kind of want to understand more after learning this lecture is basically the concept of waves. Boom. Here he used the concept of wave moving through the bat. this is another concept of the waves and vibrations. I feel like everywhere in physics we see the concepts of vibrations and waves and how that's basically applied to other concepts in physics and the world. I feel like if I could better understand these concepts more conceptually about waves, then maybe I can start understanding a lot more, or grasping a lot more things in physics and just basically about how our world works. So it kind of motivates me to kind of figure out how waves coincide to all these different factors like spring force and all that, which we've already gone over in class. But thank you guys for watching my video. I appreciate it, and have a good day.